Now we are going to discuss about round robin scheduling algorithm. In priority scheduling algorithm, we are executing the process which has the highest priority. But in round robin algorithm, there is a time quantum. CPU executes first process until the time quantum completes, or if the process execution is completed before the time quantum, then it executes the next process. Like that, it completes one cycle for all the processes. That means it gives a chance to every process to enter into the CPU first. After that, in the second cycle, it starts from the first process and completes all the processes in the ready queue. For example, there are 4 processes: P1, P2, P3, P4, and burst time 10, 5, 6, 12, and let us consider the time quantum as 2 milliseconds. Now at t equals to 0, all these are in the ready queue with burst times 10, 5 and 6, 12. Now P1 enters into the execution and completes the execution up to 2 milliseconds. Now at t equals to 12, the process with P1 8 milliseconds, P2 5 milliseconds, P3 6 milliseconds, P4 12 milliseconds. Now P2 will execute, means P1, P2, 0, 2, 4. Now at t equals to 4 milliseconds, P1 with 8 milliseconds, P2 with 3 milliseconds, P3 with 6 milliseconds, P4 with 12 milliseconds. Now P3 will execute only 2 milliseconds, and at t equals to 6 milliseconds, P1 8, P2 3, P3 6, P4 12, P3 4 milliseconds. Now P4 starts execution. P1, P2, P3, P4, 0, 2, 4, 6, 8. At t equals to 8, P1 with 8, P2 with 3, P3 with 4, P4 with 10. Now here the first stated, that means P1, P2, P3, P4 has given a chance. Now P1 again starts execution, and now in the ready queue P1 starts execution 0, 2, 4, 6, 8 up to 10 milliseconds. At t equals to 10 milliseconds, that is P1 with 6 milliseconds, P2 with 3 milliseconds, P3 with 4 milliseconds, P4 with 10 milliseconds. And now P2 starts execution. That means P1, P2, P3, P4, P1, P2, and it has to execute 3 milliseconds, but it executes only 2 milliseconds, that is up to 12. Now at t equals to 12 milliseconds, the process with burst time as P1, P2, P3 with 4, P4 with 10. Now P3 will start execution. P1, P2, P3, P4, P1, P2, P3. It executes 2 milliseconds. Now at t equals to 14 milliseconds, P1 with 6, P2 with 1, P3 with 2 and P4 with 10. Now P4 turn. P1, P2, P3, P4, P1, P2, P3, P4, 0, 2, 4, 6, 8, 10, 12, 14, 16. At 16 milliseconds, P1 with 6, P2 with 1, P3 with 2, P4 with 8. Now the second cycle also completed, and at now the P1 enters into the execution. It executes only 2 milliseconds, that is up to 18 milliseconds. Now at t equals to 18, P1 with 4, P2 with 1, P3 with 2, P4 with 8, 10, 12, 14, 16, 18. It executes only 1 millisecond, and now the chance was given to the next process which is in the ready queue. That means at t equals to 19 millisecond, P1 with 4, P2 completes its execution, P3 with 2, P4 with 8. At t equals to 19, the turn was T3. That it means P1, P2, P3, P4, P1, P2, P3, P4, P1, P2, and now P3. Its remaining burst time was 2 milliseconds, and the time quantum was also 2 milliseconds. Then it completes its execution at 21 milliseconds. Now at t equals to 21, in the ready queue there are only two processes with P1 with 4 milliseconds and P4 with 8 milliseconds remaining burst time. Now in this, P1 will select it first and starts execution. P1, P2, P3, P4, P1, P2, P3, P4, P1, P2, P3, P1, and it executes 22 milliseconds, and that becomes 23 milliseconds. Now at t equals to 23, P1 with 2 milliseconds and P4 with 8 milliseconds. Now P4 starts its execution from 23 milliseconds. P4 starts and up to 2 milliseconds, t equals to 25. At t equals to 25, P4 with 6 milliseconds, 25, and P1 come to execution, and it completes its execution because its remaining time was 2 and time quantum also was 2. Now at t equals to 27, the only process in the ready queue was P4. Now P4 starts its execution. P4, it executes only 2 milliseconds, that is 29. T equals 29, the only process with R is P4. Now again P4 comes into the execution, and t equals to 31, P4 with 2 milliseconds, and now P4 comes into execution and completes its execution. Now P4 completes its execution at 33 milliseconds. Now the average waiting time. This is the Gantt chart. Here, for calculating average waiting time, we have to calculate the individual waiting times of the processes which are in the ready queue. Now P1 waits 0 milliseconds at starting, but it waits 6 milliseconds, that is from 2 milliseconds to 8 milliseconds it waits, and 10 milliseconds to 16 milliseconds again 6 milliseconds, and from 18 milliseconds to 21 milliseconds 3 milliseconds, and 23 to 25. P1 waits total of 15, 17 milliseconds, and P2 at start waits 2 milliseconds, and from 4 to 10 6 milliseconds, and from 12 to 18 6 milliseconds, and from that's it. After 19 it completes the execution. That means 12 plus 2 14. Like this, P4 waits 15 milliseconds and P4 waits 12 19 21 milliseconds. The average waiting time equals to 17 plus 15 plus 14 plus 21 divided by 4, that equals to 32.
15.
46.
16.
67 divided by 4.
16. 64. 64.
16 4 so 64.
No, yeah.
16.8. This is